talking about motion, we're going to start talking about an entirely new category of units. So up until now, every unit we have talked about has been considered a scalar unit. Scalar units are any unit that can be defined by magnitude alone. So any unit defined by magnitude alone. And aside from that category, we're now going to be also introducing a category known as vector units. And a vector unit is any unit that has both magnitude and direction. Any unit defined by both magnitude and direction. And direction. So, quick question for you. What does magnitude mean? What does magnitude mean? What's your guess? Nope, not similar. Others. I heard that it was a vocab word in a couple of English classes. Yes? Okay, so it was maybe a while ago? Yeah. Okay. What does magnitude mean? Rate that something goes? Okay. Other thoughts? Size. Magnitude means size. Sounding familiar? Okay. So one of the things that I run into a lot of times with students is, and this is especially my physics and AP physics students, I'll ask them to say, find the magnitude of a velocity. What does that mean that I'm asking them to do? Find the size of the velocity, right? I get a lot of students, AP physics students, who will say, well, how do I find magnitude? What does that mean? It means size, okay? So if we remember that the word magnitude can just be replaced by size, it'll make your life a lot easier. So to start, examples. What are some examples of units that would probably be scalar? We've used a lot of them. They're units that don't really make a lot of sense if you use a direction after them. So what are some examples that you might think are scalar? Values or units we've used this year that are probably scalar units. Give me a guess. Pounds are an interesting answer. And actually that one, because it's a weight, is actually a vector unit. Because which way do pounds usually act? Or which way does weight usually act? Like if I say I'm 240 pounds, which way does that act? Down, right? So because weight has a direction, it's actually a vector unit. What other units do you think could be scalar? What other values that you could measure should be scalar? Volume. All right, volume. So like 3 liters or 4 gallons. It doesn't make sense if I say 3 gallons east. That doesn't make any sense. So it's got to be a scalar unit. What else can I say that would be scalar? Mass. Give me another. So height we could say is vertical. Height we could say up. But I am going to put distance here and displacement here, and we're going to talk a little bit more about those later. We're going to talk about those a little bit later, so we're just going to put them there for now. What other ones do you think wouldn't have a direction, so would be scalar? Density is a good answer. What else have we measured this year so far? Yeah. Go ahead. Weight has to do with gravity. Mass has to do with how much stuff you're made out of. So if I say something's like a kilogram, that's a statement about how many atoms are in it. Versus if I say weight, you weigh a certain amount here. If you go to the moon, do you weigh the same amount? No. Do you have the same amount of mass? Yes. So weight has to do with gravity. Mass has to do with how much stuff you're made out of. So other things that could be scalar units. What's a common one you probably check every day? Temperature and time. Okay. Pressure is also a scalar unit. All right, good. So we've got a handful there. These are the ones we probably talked about this last semester. Now, vector units are going to be things that have a specific direction. Weight acts down. Displacement. Well, this is how far you're moving in a certain direction. We can also talk velocity, acceleration, you know, the things that you just had arrows with on your simulation that you were working with. And over here in the scalars, we're also going to throw in speed, and I'll explain that one in a minute. So scalar versus vector units. Scalar units are any that don't have a direction. Vector units are ones that do have a direction. And if you're having a little bit of difficulty remembering what the definition of a vector unit is, here's some help. Get this plugged in. Restart that.
I'm applying for a new film loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Hurrah, Nagara! Oh yes! Fires like piranhas, never seen one before. Now you have, man. You have a demonstration. Oh, ow! It's so difficult sometimes to keep quiet.
All right, so vectors are units with both direction and magnitude. Yeah.
Why is it speed?
We're going to get to that in a minute. Okay, so first two units we're going to talk about today are distance and displacement. Distance and displacement. Okay, so both of these are measuring the amount of space between two locations. However, the way in which they're measured is a little bit different. When we talk about distance, distance is simply measuring the length of a path taken between two locations. The length of a path between two locations. Conversely, displacement is a change in position between two locations. A change in position between two locations. And because it is a vector unit, displacement must include both magnitude and direction. For which one we're talking about, both displacement and distance can be measured in the same units. So both are measured in feet or meters. Both measured in feet or meters. The big difference is that distance, as soon as you've moved, distance is always a positive value, but displacement can be 0 even if you have moved, because you go back to the same spot. Is always a positive value once you have moved. Displacement can be a negative value. Displacement, I'll get to that in a sec, can be positive, negative, or 0, depending on where you are compared to your starting location. On the change in position. All right, so how could the answer be negative? Well, if we think about the motion I just went through here, and I started here, and I walked 2 steps here, we said that I had a distance of 2 meters and a displacement of 2 meters to the east, right? And if I walked back here, we said the distance then would be 4 meters, but what would my displacement be? 0. So that means that one of these motions, either going 2 meters that way or 2 meters this way, one of those had to be negative because they're canceling each other out. So just like in math, where you have a positive x-axis and a negative x-axis, or a positive y-axis and a negative y-axis, when we're talking about vector units, there's always a positive direction and a negative direction. Now, which way is positive, which way is negative? Is that positive or is that positive? Why? Okay. What if I'm facing this one? So it really doesn't matter. Which way is positive and which way is negative? If I spin myself around in circles and don't know which way is north, east, south, or west, is there any way, any reason this direction is different from that direction? No. So what way is positive doesn't matter. As a person doing a problem or a scientist working a concept, you pick which way is positive, and you just keep that way being positive until you're done. Okay? So it's not even a guess so much as a decision. Because if I decide that's positive, I go 1, 2 meters in the positive direction. I go 1, 2 meters in the negative direction. My answer for my displacement is 0, right? Let's change it up.
What if you get like all 4 directions? Which one?
I go 2 meters in the negative direction. The opposite of what I just said it was, right? 1, 2 meters in the negative direction. When I go back to the start. 1, 2 meters in the positive direction. What's my total? So it didn't matter which way I said it was positive, did it? No. So just like on a graph where there's a positive y and a positive x, I could say positive x, positive y. And those would be my coordinates. Or I could say positive y, positive x. Doesn't matter. Once you make the decision, though, you keep that decision. All right. That's distance versus displacement. Our next one up is speed versus velocity. All right. By definition, speed is the average change in position over time. The average change in position over time. Velocity is then speed and direction. Velocity, speed, and direction of a moving object. Yes. Okay. calculationally, we can find this one as velocity is equal to the change in displacement over a change in time. As an equation, we're going to write that as v equals d over t. Okay, so this takes us back to our daily question today. Today we asked, if you're driving 80 miles an hour, how long does it take you to go 80 miles? So if I want to use that as my example problem, 80 miles per hour, what unit or what variable does that identify as? Velocity. I would agree that it's a scalar unit because I didn't see a direction. But in my equation, I'm looking at that as velocity because that's how fast it's going. Okay. Now I could say north or I could say south. That's appropriate. But I'm just worried about the value in terms of the equation. Next one. And I travel 80 miles. What variable is that going to be? Distance or displacement. Meaning that I'm asking how long does it take, what's the time? So plugging in these values, 80 equals 80 over t. If you are not in algebra or geometry and you have not taken those classes, this is how far I expect you to get. If you are in algebra, doesn't matter which one, if you are in geometry, I expect you to now be able to solve this equation. So, as a student in algebra or geometry or something higher, what do I do first to solve for t? Get t alone, so how am I going to do that? Okay, I like one of two options. I like divide by 80. I also like multiply by t. So if I divided by 80, I'd have divide by 80, divide by 80. I'd have 1 equals 1 over t, right? What now? Times what? Times by t. So I get t equals 1 hour. With me there? Okay. I'll go back. Just out of curiosity, how many of you have seen this one? Okay. Oh, I've got to turn off the sound again.
Logan to Boise, and I just proposed the math question to my beautiful wife, Chelsea. And the question, very difficult to calculate, is if you are traveling 80 miles per hour, how long does it take you to go 80 miles? Okay, what do you think, Chelsea? Let's go through the process. What do you think?
Well, if I run the mile in about 9 minutes.
What about the tire turning thing you were talking about? You think that affects it?
Well, I'm guesstimating probably about, it turns about 4 times in a mile.
That's just like guessing calculations.
Yeah, I don't know how you work that out.
It's gonna be tough.
Yeah, so, I don't know, because if I run a mile in like 9 minutes, then, I mean, but that's what I'm out of shape. When I'm really in shape, I'm like 7 minutes, and then I'm like really in shape. And that takes me a mile. And we're going 80 miles. I'm running at about probably 10 miles per hour, if that.
Yeah.
And that's pretty fast for a human being. But, I mean, it's gonna take me like 15 minutes or something
15 minutes? It's pretty close.
to go 80 miles.
Do you know what the answer is?
But,
Think about 80 miles per hour. So how long does it take me to go 80 miles if I'm traveling 80
you're
miles
driving
per
fast. You are
hour?
driving faster than a minute a mile.
whack it in half.
Well, depends on, I mean, sometimes tires turn faster than others.
Yeah, definitely affects it.
Because, I mean, I think a truck probably is slower because it weighs more. But I think it also matters if your car's a stick or automatic.
What?
Yeah, I know. Turn miles per hour.
MPH.
MPH. So if I say I'm driving 80 miles per hour, that means I'm going to go 80 miles in an hour.
No, you are not. Because you are driving faster than a mile a minute. I can run 1 mile in 7 minutes. And that's a 10. Okay? So, I mean, that's booking it too.
Okay, so if I'm going 60 miles per hour,
Then you're probably, it'll take out 30 minutes. I would just put it right in half.
I'm trying to explain the answer, but
Well, you are not making sense because I make sense, you do not make sense. My car's tires may be a little, they're kind of a little flat, so they may not be the fastest. It's just police officers' tires that are full, but I just,
okay, tell the
my
answer.
tires are turning maybe, I'd say about 400 times per mile.
Okay, I'm going to tell you the answer. You ready for
So
the
they
answer?
gotta be like 1,000.
You ready for the answer? The answer
You
to...
don't know the answer.
I do know the
You
answer.
guessed me just like I guessed me.
Just a meaning of amazing math, science. I'm using my own term. Okay, Chuck. The answer to the question, how far, no, how is it to travel 80 miles if I'm driving 80 miles per hour? The answer is 1 hour. Your guess was close.
So say you drive 60 miles per hour at 60 miles. If you want to go 60 miles at 60 miles per hour, is that an hour?
Yep.
What about 40 miles at 40 miles per hour?
And you will go 40 miles in 1 hour.
You cut that in half.
So, hopefully we understand that it should be an hour, and the answer to the daily question was 1 hour because we used math and science.
You put it back on your nose.
Yep. Now, a couple more things. Not yet. The reason I show you this video, because initially when I saw it, I kind of thought, oh, this is funny. They totally staged this. This is faked, right? And looking around, I'm seeing you guys laughing or just kind of in disbelief. And that's most students' responses. However, I have had 2 students in the last 8 years who thought she was right. So we had a lot of work to do. For tomorrow. Hey guys, not standing yet. Steal your chair back. For tomorrow, I want you to be able to answer questions 5 and finish the rest of the page. So question 5 asks you about a vector diagram. A vector diagram is simply an arrow that shows you the direction and magnitude of a vector at any point in time. So what would this look like on your simulation? That arrow in the bottom right-hand corner, right? So the question asks, use your knowledge of vector diagrams. The fact that an arrow shows us the direction and magnitude of a vector. The larger the arrow is, the higher the magnitude is, and then the arrow points in the direction you're moving, to explain why your strategies from question 3 worked. The other part of this is I'm asking you to go to this website and read their definition of acceleration. I've included the highlights for you here. Okay? Based on that definition and these highlights, create a concise statement about how the description of acceleration applies to the strategy you used in question 4. So you're using this definition to say, this is why I had to do what I did in problem 4. Lastly, you're comparing and contrasting velocity and acceleration. What did you have to do differently when you used the velocity arrow versus when you used the vector arrow? or sorry, versus when you use the acceleration arrow. So how are those two steps different? Now you can put your stools up. Is your name on this? I'll be able to figure it out then. Tomorrow when?
I can do after school. No, that works for me. We'll do that for that.